Okay, basically our project is designed to help someone new park in a large parking space. The user texts a chatbot. The chatbot responds by telling them which parking slot is available according to the entrance they're at. The project has three main parts. The first part is the bot, which communicates with the server. The second part is the server itself. The server has all the information about the slots. And the third part is the Arduino part. The Arduino part is connected to the parking slots, which have an RGB LED and a sensor. The sensor detects its availability, whether it's occupied or not, and it sends this data to the server. The server then sends this data to the bot, which communicates with the user. If a user wants to reserve a spot before parking in it, it texts the chatbot, which communicates with the server, and the server then sends this data to the Arduino, which flashes blue to indicate that this parking spot is reserved. If the user doesn't get there in time, which is about approximately 2 minutes, the status then goes back to available instead of pending. Okay, so let's start with the Arduino part. The Arduino is connected to 4 parking spots. Every parking spot contains an RGB LED and an infrared sensor. The RGB LED indicates the status of the parking spot. Green means available, blue means pending, and red means occupied. Pending means that the user requested the spot from the web server.
Okay, so let us proceed. How does the Arduino send the status of parking spot to the web server? We used a microprocessor similar to the Arduino called Node MCU. This microprocessor contains a Wi-Fi shield that makes the Node MCU act as a web client and sends requests to the web server containing the status of the spots.
Hello there, I'm Carol. I developed the chatbot on a texting platform called Telegram, which helps the user find the nearest empty spot relative to the entrance they specify. So next I will be talking about possible scenarios between the user and the chatbot. So the user initiates a conversation with the chatbot, and the bot asks the user to specify his entrance. Then the user specifies his entrance, which is entrance number 1, and the bot finds the nearest empty or available, as indicated by the LED with a green light, spot to this specific entrance. In that case, it's A21, and then the bot asks the user to confirm if they want to reserve it. When the user confirms that they want A21, the LED indicator turns blue, meaning that this is a pending spot. Within a 2 minutes range, this spot remains pending, otherwise it's made available. In the second scenario, we only care to emphasize that if the user declines a suggested spot, they can proceed to make one of two choices, whether choose another spot, meaning choose a spot different than the one they already declined, or reserve a spot generally, which could mean that they would get the spot that they had just declined. In that case, the user first received A24, which he refused, and then got A23 when he chose to choose another spot. In the third scenario, we only care to emphasize that the pending status is maintained for at most 2 minutes, and then the spot is made available for other users.